Hi everyone! In today's video we will do an analytics project together. If you don't know me, I'm Karina. I'm self-taught data analyst and data scientist. I transitioned from finance to data analytics over 10 years ago, and now I share my knowledge with other people online. For today's project, I used a US health insurance data from Kaggle website. The link to the file is in the description. You can create an account at kaggle.com absolutely for free and also download this file. I must admit I had to change the name of one column from original dataset, and I changed it to gender because if I keep repeating the original name, this video can get banned. And at the end of each blocks, I will explain what you probably should be writing in your analytics report. So let's look at the data.
I will be using Jupyter Notebooks. You can use Visual Studio Code or Google Collaborate. As a first step, you need to install Pandas library because this is a module we will be using for our data analysis. To do that, you need to use the following code: pip install pandas. And then you run it. Since I already have it installed, it tells me that requirements already satisfied, but if you're doing it for the first time, it will install the module. As the next step, you need to import your pandas library. So import pandas as pd, so we give aliases, so we don't need to call it pandas again. And then we create in a new data frame, df equals, we need to use our pandas module, so pd.read_csv, and then in the brackets you give the path to your file. I will copy it. Finally, after that, we can print our data frame and see how it looks like. Okay, so that's our data set. As you see, I changed the name of the column as I mentioned to you before. So now we need to do our data analysis. I suggest us to do descriptive statistics and frequency counts. So you can calculate that for numeric columns separately, for each column separately. For example, you want to calculate the average age. To do that, we need to say data frame name dot age dot mean and then empty brackets, and then we can print it, and it will give us the average age. So you can do exactly the same thing for each numeric column, so for BMI, for children, etc. Or you can use dot describe. And dot describe is almost like a magic. So it gives you count, mean, standard deviation for all of the numeric columns at once. So now if you need to write your analytics, you can just use this table and, for example, say that age, the mean age is approximately 39 years and the standard deviation about 14 years, indicating moderate age diversity within the insured people, and that our age range is from, so let's have a look at, from 18 minimum to 64 maximum. About our BMI column, we can say that the average BMI is around 30.7, which is our mean, and we typically classify as obese. From internet, I know that if BMI is equals or greater than 30, it's considered as obese. Unfortunately, we can see that average BMI is 30.7, indicating that average insured person is in an obese category. The values range from 15.96 to 53.13, showing a broad variation of body weights. As for children column, on average, individuals have about one child, with a maximum of 5 children. As for charges, insurance charges averages about 13,270, but vary widely because we can see the standard deviation is 12,110 and our maximum charge is almost 64,000. Once you do your analytics, you need to put together your findings, and I think that dot describe helps you a lot to quickly summarize this information. To get information for our categorical data, we will use a slightly different code. Columns like gender and region is a categorical data, it's not a numerical data. We will say df dot name of our column, gender, dot value underscore counts, brackets, empty brackets, and run this code. It gives you a count for male and female, or count for all the categories in the column. If you keep the brackets empty, it will give you just a numbers. You already can say that our data set is balanced in terms of gender, and we have 662 female and 676 male. But another thing, if in those brackets you add one line of code, again we will just copy this, and then in the brackets you say normalize equals true. and it will change the count to percentage. So if you want percentages, it's very easy. So now you know that 50.5% are male and the rest are female. I have another line of code that can help you to analyze all the categorical data at the same time. So we will say categorical counts equal name of our original data frame, which is df, select underscore d types. This way we can say which data type specifically to select, brackets. In the brackets we need to say include equals square brackets and then object, and I will explain why, dot apply unders dot series dot value counts. And this code print what we've got. And here we are. We could have done what I've shown you before, just repeating for each categorical column, or we can do all the categorical counts at the same time. So I'll explain to you what this line of code does. So select types is a method in pandas that allows you to select columns based on their data type. So you can say just integer or float, but in our case I selected object. Why object? So typically object means that the column has a mixed data type. So it can be a string and an integer, and categorical data in our case is object type. Dot apply is a method that used to apply a function along axis in the data frame. Pandas.series.value counts is a function used to count the number of unique entries in series, returning a series showing the frequency of each unique value. Now we can do analysis of our categorical column. So we can say regarding gender that dataset is balanced with 50% 0.5 male and 49.5 female. Otherwise we can say that we have 676 male, 662 female. For smokers, most of the insured customers, 1064 individuals are non-smokers, while only 274 are smokers. And as for the region, the distribution across regions is relatively even, with the southeast having a slightly higher count of 364. So as a next step, we need to start creating some visuals. I would suggest to examine the correlation between numeric variables and create visualizations to better understand how these factors like age, BMI, and smoking status impact insurance charges. I will also look at how gender and region might affect those charges. For visualization, we will be using Seaborn and Matplotlib. We need to import these three libraries: Seaborn, Matplotlib, PyPlot specifically, and NumPy. Usually when you creating visuals, the next step is to select the figure size. So you use plt.figure, and in brackets you say fig size, which is the size of the figure, or how big or small your graph will look like, and then you give numbers. So I say 10 by 6. Then I want to create my correlation matrix for numeric columns only. It will give you an error if you want to create for the whole table. So correlation matrix works for only numeric columns. I'm creating a separate data set called numeric data. So we'll say numeric data equals name of the original data frame, and then we will select only numeric columns. As I showed you before, we will use select underscore d types, brackets, in brackets include equals, and then in brackets we say, you can say integer and float, or you can say numpy dot number. That will create a new data set or data frame that has only numeric columns. Now we do correlation matrix, which is numeric data dot core and then empty brackets. Then we use our Seaborn for heat map visualization. SNS or Seaborn dot heat map brackets correlation matrix, comma not equals true, comma CMap equals, this is where you select the style. I use cool warm. And to display your matrix, you do plt.show. And let's run it. If you made so far in this video, please click the like button. It helps me and the algorithm to reach more people. Okay, I made a spelling mistake. And here's the result. I didn't add title, it just show as an example. So plt.title, and in brackets you say metrics, and that adds the title to the visual. Let's have a look at what we've got. How to read it. So we can say that correlation between age and charges. So there is a positive correlation of 0.3. So it's indicating that charges tend to increase with age. The next one is BMI and charges. So similarly, there is a positive correlation of 0.2 between BMI and charges, and it also suggests higher charges for individuals with higher BMI, because probably they have higher health risk. Let's look at children and charges. The correlation is weaker, but it's still positive, 0.07, showing that the number of children has a less pronounced effect on charges compared to age and BMI. As the next step, let's create a scatter plots for age, BMI and charges. Look how it's affected by smoking status. We again will use Seaborn, so CNS dot, and this time we are using our pairplot. Name of the original data frame, or DF, comma, vars equal brackets. You need to indicate which columns we want. We want age, we want BMI, and we want charges. And we add a hue as a smoker status. And again, we use plt.show to see our scatter plot. So you can see that yes is blue and orange is no. This pair plot highlights relationship between different numeric variables with smokers and non-smokers indicated. This visual can help us to see how smoking status affects the charges. And this can help us to visually see patterns such as how smoking status might influence relationship between age, BMI and charges. We can also look further into investigate the influence of categorical variables like smoking status and region on insurance charges through some comparative statistics. So let's compare insurance charges for smokers and non-smokers across different regions. So let's look at average charges for smokers equals name of the original data frame, or DF. Then we will group by our data by the column smoker. So we want to group by smoking status. And then we want to look at the column charges. So in square brackets you say charges, and we want to see the average value, which means dot mean, empty brackets. Let's do average charge by region. So it will be average charges by region equals, again, name of the original data frame, which is DF, group by, and this time we will group by region, and in square brackets what we want to summarize. In our case we want to summarize charges, and we want to see the average, so dot mean, empty brackets. In the same way you can calculate the total, which is sum, or you can get the maximum value, minimum value, or average value. So we can see that by smoking status, average insurance charges for non-smokers is around 8,434, while for smokers average charges are significantly higher, and they increase up to 32,050. Massive difference. If you look by region, the average charges are approximately 13,406 for northeast. For northwest it's almost 12,500, in southwest 14,735, and southwest is again 12,346. After all this analysis, we can make conclusion that smoking status is probably the most significant factor affecting insurance charges, because clearly smokers incur much higher costs. For regional differences, we can see that there are variations in charges across regions, with southeast being the most expensive on average. There are still so many things you can look at. You can look at gender and ages and look at their charges. So for example, you can look at, is there discrepancy of the average insurance charges between male and female with different number of children. You can group BMIs and say if it's between 25 and 30 it is in overweight, and if it's above 30 it is in obese, and look also how many people you have in those categories, percentage-wise. So there are so many things you can look at, but I think as a general analysis, we found which factors have the most significant impact on the charges. And so that's how you do quickly your data analytics on the new data. Please don't forget to click a like and subscribe button. I will be very, very grateful for that. Please let me know if you want me to do more of those tutorials. Also, you can send me which specific data set you want me to look at, and we will analyze it together. So thank you and see you next time.